scientific papers are not all the same when speaking of power of the scientific evidence, and I will talk you about it in this video. Episode number 3, the pyramid of scientific evidence. Welcome to the third episode of the Jumbo Science channel. First of all, sorry if this episode arrives so late, and yes, probably one episode per month was very challenging for me, so probably would be one every 2 or 3 months, but still, thank you very much if you're still willing to follow me. Thank you. So, let's continue this set of these first 4 episodes that are more introductory episodes for my entire YouTube channel, while from the episodes 5 I will try to tell you a little bit more of what I do in my research activity. This episode, here we go with the pyramid of scientific evidence. Not every scientific paper is the same, and each study that I mentioned here means that it's a scientific paper like I described it in the episode 1, and it has been peer-reviewed like I described it in the episode 2. The idea of the pyramid is that the studies at the bottom of the pyramid are not meaningful or something like that. No, it's just that the more we go on top on the pyramid, and the stronger is the scientific evidence. There are plenty of studies that have been published nowadays. But the thing is like to understand the knowledge is like a puzzle. And every study can be a piece of a puzzle. And a piece of a puzzle is still very important. But to be able to see from above this complexity, because science is super complex, to understand this complexity, this pyramid can give you an additional tool to understand scientific evidence is never related to a single study. To have a very stronger evidence, more studies needs to be published with the results that agree each other. Now you can see the type of study, how they are placed in this pyramid. So the more we go on the top, the stronger is the evidence. We can start with somehow at the bottom things that are not really studies, even though they are published on scientific journals, and they can be opinions of experts, or they are the so-called letters to editor. So something that is just maybe an opinion of an expert, still important, but not really in itself a scientific data sometimes. Then we can put study conducted in the laboratory, like in vitro studies, for example, on cell cultures, and animal studies. Still, these studies are important because, for example, to evaluate the toxicity of a compound, we cannot give, for ethic reason, a toxic compound to a human. The advantage of this type of study is that these studies are super controlled. So when I will speak later about study conducted on humans, we cannot put humans into a cage and control everything. There are plenty of confounding factors that we are nowadays exposed to, and plenty of confoundings that can limit the evidence to study something in particular. While when we study something in the laboratory, we can control everything else. Then we start with the analysis studies conducted in human. One of my is epidemiology. So epidemiology is the study of a particular pathology or particular condition in the population, and how environmental factors or the different factors into an organism can affect the development or not of these conditions. We can start with case reports. Case reports are like when something very particular happened and a physician, for example, want to report this to the entire scientific community, they just publish a few pages article. Case series, similar, but maybe when this happens to more than once. Then we can go up in this pyramid. We have a stronger evidence when we speak of cross-sectional studies. A cross-sectional study is a study in which we are looking at the population like if we do a picture. In this case, we are just looking to a certain number of persons. We just see that these persons have these pathologies, these conditions, and then we can say, oh, also this person to have this pathology also have these particular factors, or this happening to this person, but it's just a picture. The disadvantage of this is that we cannot speak about causal inference in this type of study. With this type of study, generally we cannot determine the cause and the effect. Case control study. In case control study, instead, we are still kind of taking the picture of the situation, but we are also trying to gather information to retrospectively understand what happened. Generally, in a case control study, we establish a certain number of persons who have, for example, a specific pathology, and a certain number of persons, generally matched, that don't have the pathology. In this way, we try to collect information and try to study retrospectively the reason why this number of persons developed the pathology and this other number of persons did not. And then in a higher place of this pyramid, we can put the cohort studies. Cohort study is definitely more challenging, more expensive, because in a cohort study we are taking a certain population, especially in prospective cohort study, and while the previous were like a picture, this is more like a film, because in cohort studies we are taking this population and we are following this population over time, in prospective cohort study at least, and then we are trying to see who of them develop or not a specific pathology or condition of interest, and since we are following this person, we are also gathering information, or we are analyzing samples, or we are collecting data about these persons to try to understand what are the reasons. With this type of study, different to the others, we can draw a better cause to effect relationship. Finally, we have randomized control trials. While the other type of studies in humans described so far are referred to observational studies, so that we, in the other studies that I described so far, we are just observing the population. In a case control studies, we are actually giving something. We are giving a treatment, a molecule, something that we want to study. Or for example, in nutrition, we are giving certain food, I don't know, whatever. In a randomized controlled trials, we usually take a certain number of persons and randomizedly put those persons in group 1, and another group of persons will be randomized placed in group number 2, and all these persons will still be kind of similar in terms of age or sex, for example, and then we will give to the group number 1 the molecules of interest or the treatment of interest or whatever we are studying, and the group number 2 nothing, the placebo. To improve also the scientific soundness of this, we can also use the strategy of using double blind. In a double blind randomized controlled study, we make sure that nor the patients and nor the clinicians that is giving the treatment actually know that which of the two groups are actually receiving the treatment and actually receiving the placebo. Okay man, you convinced me, but if the last type of studies is the best one in terms of scientific evidence, the randomized and controlled one, why don't we always use that ones? Yes, we cannot do randomized and controlled trials all the time, not only for the cost, but also because, for example, there are plenty of cases in where we cannot give the subject what we want. For example, what I usually do in my research activity, I study, for example, environmental pollutants, something that can be potentially toxic, and of course, for ethic reasons, we cannot give a toxicant to a person on a purpose. Then at the top of our pyramid, we have reviews and meta-analysis. Reviews is a collection of different papers and descriptions of different studies all together in a single paper. A systematic review is something more, because we are systematically looking for a specific type of paper in a systematic way, and even better, systematic review with meta-analysis. A meta-analysis is like a study of study. If we, for example, take 10 different cohort studies, and these 10 different cohort studies were conducted for the same reason, so for studying the same topic, we can quantitatively put the data together, and like if we take all the 10 different populations of the 10 different cohort studies, and we combine them together to have a single study that includes all the population, like to having an increased number of persons, and of course, with an increased number of persons, we have a stronger evidence. I would also mention a paper written by Mural and co-workers in where they proposed a new evidence of pyramid in which the final level is chopped off and we consider the systematic review with meta-analysis, which are not original studies but are, again are a overview of other studies already performed. They are like a lens when we can look at the scientific evidence considering other studies that have been performed. And also they use these waves to indicate that the line is not that different sometimes, because for example a cross-sectional study very well performed, maybe with a very high number of persons or that can be evaluated as very well performed, can potentially produce a stronger evidence than a case control, for example. Cool! Well, I hope that I gave you an overview of the scientific evidence and thank you very much again. And remember, science is fantastic! Okay, I was not sure about doing this, but yes, maybe it can be something that is usually done here on YouTube, so let's do it. Yes, let's do it. Subscribe to the channel!